Hi everybody, last video for day 17. Just want to quickly go over the relationship between sorted and sorted prime. There's some optional exercises here, no actual work for you to do, but I still think it's worthwhile content to take a look at. So if you remember, sorted prime said, okay, here's a different way to think about sortedness. Pick two indices into the list, one before the other, and neither of them over the end of the list, right? That's what this little I less than j less than length al means. And if I look up the ith index and I look up the jth index, the value at the ith index should be less than or equal to the value at the jth index. So if you're used to reasoning with arrays from your earlier programming experience, then this may seem like a really natural formulation compared to the inductive proposition that we've used. So maybe this is a better one. So there's two parts here to the sort of optional exercises. One is we can prove that these are equivalent. It turns out to be pretty hard work. Reasoning about indices is really hard. Um, there's some hints here. I'm happy to talk people through this if you attempt this and get stuck. It is complicated. You need to be pretty good with the less than or equal to reasoning and stuff like that. And it's just really hard to keep track of what's happening, but it's totally doable. You can prove that it's an if and only if. These two definitions are totally equivalent, right? It's a perfect characterization of what's going on. But you can totally do it. And then, so this section lets us see that, okay, these two are equivalent. You could really use either and you'll get the same level of confidence at the end. So how might you choose one or the other? And then the next bit here is asking you to sort of think about what would it look like if you only knew about sorted prime, right? You didn't know about inductive propositions, so you're just going to talk about indices. What do you need to do? And then here I say it's like, okay, well, let's try it. Try to prove insert sorted for sorted prime, right? If something is sorted prime, then so is inserting something, and then sorted prime holds for sort L. This is a hard proof. It's really long. It's pretty complicated. You need tons and tons of lemmas. Um, it's quite a thing. It's honestly quite a thing. And I think there's kind of a moral here. This moral is actually stolen from Andrew Appel, who wrote up originally a bunch of this material in this file for his course at Princeton. If you didn't know about sorted, you might think that proving sortedness, like that this sort is correct, would be really hard. But choosing the right specification to prove can really make the difference between it being easy or not, or you being able to do it or not. Kind of a big deal. So I think to me that's a really interesting moral that like not only do you have to work hard on your programs, you have to think carefully about your specifications in terms of what's going to make it easy for you to do the proofs that you need to do. I don't know. Food for thought. Take a look here. It's a great spot for extra practice, but I do want to make it very clear that these are hard proofs, and I don't expect people to sort of find these straightforward or easy or even necessarily able to finish in any way. Put them out there just as exercises for y'all. All right. Cheers. Have fun with the rest of the day.